Hello everyone, and welcome to the demo of Team 2 for the final week. This week we are going to look into how to implement NFA. So as you can see, we are reusing the panel that we have been using for the past 6 weeks to get the same look and feel and consistency. So we'll be starting off by constructing NFA using circular states and lines and arrows that represent transitions. Later on, we'll see how we can visualize NFA that makes it more understandable to someone who is new to it. So let us start creating the NFA. To do that, we'll drag and drop states from the left panel. Now, as you see, as soon as you drop the state number gets displayed on top of it. So let's create more states: Q0, Q1, Q2, Q3, and Q4. Now let's make some transitions. So a transition between Q0 and Q1 represented by A, and a transition between Q0 and Q3 again denoted by A. Now this shows the non-deterministic nature of NFA, where Q0 on taking input A can either go to Q1 or Q3. Now we'll create a self loop on Q1 with a transition epsilon. That means that without taking any input, Q1 can self loop on itself. Now we'll just complete this NFA by making a self loop on Q0 with a transition A, and Q1 to Q2 with a transition B, Q3 to Q4 transition B, and self loop on state Q4. Let's make Q0 the initial state and Q2 the final state. As you can see, it would be difficult to visualize this NFA for someone who is new to it. So we provide an intuitive display for this NFA, which will be presented in the upcoming screen. But before going there, it is important to understand that NFA produces a tree-like structure which can go to infinite levels. So because of the obvious constraints, we'll be showing only 4 levels of the tree structure. So on clicking of this play button, you can see the tree structure that has been generated here. So the Q0 being the initial state. So on input A, it can either go to Q0 again, which was a self loop in our first screen, on to state Q3 or state Q1, and Q1 without taking any input, that is an epsilon transition, can self loop on itself, and similarly the whole tree structure has been formed. We allow the user to test any input string against the NFA that was created in the first screen. To do so, the user has to enter the input sequence in the text box that is provided below and click on the test button. So for example, if the user wants to test a sequence AAB, the user has to enter that in the text box and click on the test button. We'll now show a step-by-step evaluation of the NFA against the input sequence. So on accepting the first transition A, the NFA will reach 3 states: Q0, Q1 and Q3, which are represented by trees here, and apples represents the transition. Moving on to the second transition, which is again A, as you can see, there is no path from Q3 to any other state on transition A. That's why the whole path has been made black and white, which represents that there is no possible path here. But from Q0 you have a possible path to Q0, Q3 and Q1 again on transition A. That is why it is colored. And similarly from Q1 we had an epsilon path to Q1. That's why this is again colored. And taking the last character B, so now you can see all the possible paths from Q1 to the 4th level on taking the input AAB.